Testing. Okay, here we are. We're live. This is section 8-4, I think. 8-4. 8-4. 8-4. And this. This video is. Should we start again? I'm waiting. No, it's okay. Come on. Okay, this is 8-4, and this is known as the free lunch program. Oh no, well, sometimes I refer to it because it's the binomial theorem. Okay, binomial. If it's binomial, it's the free lunch program. You know. So okay, just I had to tell a joke on my video. Okay. Thank you. I made that one up a long time ago. So the binomial theorem is a way to expand binomial expressions. So it looks really ugly, but this is why I don't like to use the Moby board. But if you have something like this, x plus y to the n, let's get rid of this guy over here. Okay, put him down here for now. We can hide him. Okay, x plus y to the n. How many of you have seen the binomial theorem before? A few of you. Maybe you saw it last year. Did you do it last year? Oh, in ninth grade. Okay, but it looks really ugly. You have this thing, and then you have one of these, and it's in here because we see these things. Means add them all up. R equals 0 to n of n. Oh, we have to get some better. N C R x to the n minus r times y to the r. Isn't that simple? No. You know what that means? Okay. It's not as bad as it looks, okay? So this is a combination. You guys know what combinations are? There's a button on your calculator. You could also, I'm going to show you they involve factorials. That's why we talked about factorials a little bit. We'll talk about factorials a little more when we talked about probability. But this is the combination of n items taking r at a time. I'll explain what that means. Okay. There's a button on your calculator that will do this for you under math. You go to probability. I'll show you in a little bit. Okay. N minus r. So this is just the exponent of the first term, and r is the exponent of the second. Okay. When I expand this thing out, okay, it looks like this. I'm not going to go through everything, but it looks even uglier when you expand it out. It's NC0 x to the n r times wait, that's wrong. I was looking at the wrong thing. Okay. X to the n r to the just x to the n. It's r to the 0, but there's nothing. R to the 0 is 1. So it starts with that. Okay. Then it goes plus. It does go plus. That's why I like to write it. Plus NC1 x to the n minus 1 r to the 1. Okay. Then it goes. Whoops. Again, I messed. Sorry. I'm sorry, you guys. That should be a y. Y to the 1. Then it goes plus NC. Guess what goes here? 2 x to the n minus 2 r y to the 2. Then it goes plus dot NCN, which is just 1, x to the 0, which is just 1, x to the 0, y to the n. Okay? So basically, it starts off with this exponent being the same as this exponent. N combination 0 is 1. N combination 1 is just n. We'll talk about some of those rules in a minute. But I'll show you. First, I think I have to do some stuff on factorials. But this is the general formula. Okay? So what it says, we'll talk about the combinations in a minute, but notice that this number, there's really a y over here. The thing to remember is this number is the same as this number. This number goes up here. Okay, so this is the same as this. This is the same as this. As this changes, okay, this number agrees with this, and this number's going down by 1, and this number's going up by 1. See that? Okay, this goes up 1 each time. 1, 2, 3, until you get to the nth term, and this number starts at 0, and this number starts at 0 and goes up 1, and this number starts at n and goes down 1. You'll see in a minute. Okay? But first you need to know something about what NCR means. So NCR means combination of n things. You use this a lot in probability. We'll talk more about what specifically it means. Sometimes they write it like this instead. Okay? Like this. These mean exactly the same thing. And what it means is n factorial. What it is n factorial over r factorial times n minus r factorial. So, for instance, okay, 10 combination 3. Okay? 10. Have you done combinations before by hand? 10 combination 3 means 10 factorial. They see 10 combination 10 factorial over 3 factorial, because this is r, times what factorial? 7 factorial. And you can do that on your calculator, but if you have really big numbers, your calculator is going to get an overload. So what you should learn to do is learn to, if they ask you to do this by hand, which I probably will on a test at some point, 10 times 9 times 8 times 7 factorial, right, because we keep going down, 7 factorial divided by 3 factorial times 7 factorial. What happens to the 7 factorial? You can cancel those out, right? So then you have 10, whoops, why did I write 8? 10 times 9 times 8 divided by what?
3 times 2 times
3 times 2 times 1. Wait, yeah, 3 times 2 times 1, which is 6, right? And then you could just divide whatever this number is by 6. 90 divided by 6 is 15, right? 15 times 8 is, right? 15 times 8? Is that right? 120. 120. So if I did this comes out to be 120. Okay? So that's it. No, I'm done. 10 times 9 times 8 divided by 6 is 120. It is. Right? I promise. Yes? So that's how you do a combination. Some rules about combinations, which is important to know for this, is that some rules, n combination r is exactly equal to n combination n minus r. Okay? So in other words, like 10 combination 3 would have exactly the same value as 10 combination 7. Right? So this is, if it's 10 combination 3, which I just did, if you did 10 combination 7 on your calculator, you would get exactly the same thing. You want to see how you do a combination on your calculator? I'll show you in a second. Also, n combination n is just equal to 1, and n combination 0 is also equal to 1. Okay? So those are some rules that you should know about. Combinations. And I'm just going to show you on your calculator how you do combinations. Oh, look, it's right there. Okay? So I'll move this over because I know you're working. View, show hide key press, switch. There we go. View. Whoops, sorry. How do I get rid of that window? I don't know. What? Show hide view 3. There. Okay. So to do a combination like 10 combination 3, you go 10, then you go math, then you go over to PRB or probability, and then you get n combination. There it is, NCR, and you hit that. So first you have to hit the 10, then you do 3, and hopefully I get 120. Okay, and that should be equal to 10 math combination 7. So it's over here at PRB. PRB should be the same as 10 combination 7, which, there it is. See? So I just showed you those are exactly the same. Isn't that cool? Okay, so that's how you do it with a calculator. Now you're ready to use those to do the binomial theorem? Binomial theorem. Yes? Okay. Also, I'll tell you at the end how you can use Pascal's triangle to find these. Do you know how to use those? Watch. Maybe I should show you right now. Okay? Because this is kind of for the smaller combinations and permutations. Pascal's triangle can be used to find combinations. Watch. Do you know Pascal's triangle? There it is. 1, 1. We did it. We did a coloring activity with Pascal's triangle. Remember? 1. You add up the two numbers above. So what goes here? 2, 1, 1, 3, 3, 1, 1, 4. What goes here? 6, 4, 1. Let's do one more. 1, 5, 10, 10, 5, 1. Okay? So watch this. This is really cool. If I want 4, 1, 0, 1, 2, 3, 4, 5. If I want 5 combination 2, I go down to the 5th row and over to the 2nd column. You count but the top row and the first column has to count as the 0th row. So this is the 0th row, the 1st row, the 2nd row, the 3rd row, the 4th row, the 5th row. So 5 combination 2 would be 5th row, column 2. This is column 0, column 1, column 2. So this number right here is 5 combination 2. In Pascal's triangle. This number is 5 combination what? 3. Which I can show you that that's true, right? 5 combination 2 is 5 factorial over 3 factorial over 3 factorial 2 factorial. N minus r, that's r. And that's 5 times 4 times 3 factorial over 3 factorial times 2 factorial. Cancel those out. 2 factorial is 2. 5 times 4 is 20. 20 divided by 2 is 10. Isn't that cool? Okay? So if you want it, the only problem is if you want like 10 combination, you have to draw a huge Pascal's triangle. You know, you have to like keep going, but it does work. All right. So how do you do that? Any questions so far? Are you excited about this? I've already told you lots of jokes, so I can't tell you anymore. Especially since I'm on a story. No, especially not since I'm on tape. I'm on record right now. I could be incriminated for the things I say. X plus 2 to the 4th, and they say expand. So what's nice about the binomial theorem is normally you'd have to multiply x plus 2 times x plus 2 times x plus 2 times x plus 2. That kind of pain in the neck, right? So I start with, so I'm going to write it all out so you know what instead of using the combination, I'm going to start with 4 combination what? Now where does it start? Going back one more, okay? 4 combination 0, okay? So the first term is, I'm writing it like this just because I don't have to keep writing that, see? So it's going to start at 4 combination 0, okay? 4 combination 0, that's a 0. X to the exponent up here, which is 4, okay? Not time to go yet. 2 to the 0, okay? So this plus this always adds to this, okay? This always agrees with this, and this goes down and this goes up. So the next term is going to be 4 combination goes up by 1, okay? The next term, this goes down by 1, right? And this goes up by 1, 2 to the 1. Yeah, easy enough, okay? Then the next one's going to be 4 combination 2. This one goes down by 1, okay? This one goes up by 1, okay? Then I have 4 combination 3. This one goes down by 1 to plain old x to the first. This one goes up by 1 to 2 to the third. And then you stop once you get to 4 combination 4. Now you have x to the 0, right? And 2 to the fourth. So that's what it looks like in expanded form. And then you just have to do the math to figure out what's anything combination 0? 1. X to the fourth. So that first term just becomes what? X to the fourth, because 2 to the 0 is just 1, right? So the first term becomes 1. Anything combination 1 is just itself. Like you'll kind of learn some of these rules as you go. So that's 4 x cubed times 2, okay? And we'll, right, times 2, so it's times 2. This next term is going to be 4 combination 2. Uh-oh. What's 4 combination 2? Let's go back to Pascal's triangle. 4 combination 2, fourth row. 0, 1, 2, 3, 4. 4 combination 0, 1, 2. 4 combination 2 is 6, right? 0, 1, 2, 3, 4. 0, 1, 2. 4 combination 2 is 6. So I'm going to go here, and so I'm going to get 6 x to the, why did I put a cube there when it should be a square? That should be it. No, that was right. I'm sorry. I'm right. This goes down to 2, and this goes up to 4. 4. I was looking at the wrong one, right? Times 4. Okay? Then you go 4 combination 3. 4 combination 3 is going to be the same as 4 combination 1, which is going to be 4. Okay? X to the 1, 2 to the third is what? What's 2 to the third? You know that. 8, right? And the last term is going to be 4 combination 4, which is 1. X to 0, which is 1. 2 to the fourth, which is 2 to the fourth, 16. Okay? And then you simplify a little bit more by multiplying the coefficients or the constants together. So 4 times 2 makes 8x cubed. 6 times 4 makes 24x squared. 4 times 8 makes 32x. And plus 16. And that's what you would get if you multiplied x plus 2 times x plus 2 times x plus 2 times x plus 2. Isn't that cool? How many have done that before? Oh, never mind then. I still got to teach you more. No. Is that okay? No. It's not okay?
Not at all.
Not at all. So what if I want to do something like, I'm not going to do the whole thing, okay? But if I wanted to do something like 2x, what if I have 2x minus 3 to the 5th power? Okay? So just to kind of show you how that would start, what would be my first combination? What would go at what would be the first coefficient? 5. Whoops, that's a 5. Come on. 5, what goes down here? 5, 0 times now you take the whole chunk, 2x, and you raise it to the fifth power, right? So you don't just take the x, you have to take the coefficient with it. So it's 2x to the fifth power, and here's where you have to be careful. Minus 3 in parentheses, because you'll mess up your sign if you don't do this. Raised to 0 power. Well, that's 1 anyway. The next term is going to be 5, combination 1, 2x quantity, right, to the fourth power, negative 3 to the first power, okay? Yes? And so on, okay? I'm not going to finish it up. But just so you know, okay, the last term would be 5, combination 5, 2x to the 0, right? 2x to the 0, negative 3 to the what? To the 5. This one ends where this one starts, right? This one ends where that one starts. Not that hard, right? Let's just do one more, and then I'm gonna sing to you. No, I'm not. I'm just kidding about. I'm just kidding about that. Okay. All right. So, what? Oh, that heard someone's listening on headphones at home in the studio audience. Hey, we should have fake applause every once in a while. Okay. So what if they say find the coefficient of x to the 8th in x squared plus 2 to the 12th power. So this is where you got to be kind of clever. Find the coefficient of x to the 8th in x squared plus 2 to the coefficient. This is a tricky one, okay? Because you know that if I have an x squared, what do I have to raise x squared to get an x to the 8th?
The fourth.
The fourth power. So the x squared is going to be being raised to the fourth. That means that the 2 is going to be raised to because the expansion of x is 12. These two have to add up to this. So what's this? 8, right? Then the combination is 12. This number agrees with this number down here. See that? Okay? So that's 12 combination 8. So you can do that on your calculator. So it'd be 12 combination 8, x squared to the 4th, 2 to the 8th. So the coefficient, this is just a variable here. The coefficient is going to be this times this. See that? Okay, the coefficient, the number that goes in front of that term. So it's going to be 12 combination 8 times 2 to the 8th. If I multiply 12, that shouldn't be 18, that should be 8. I'm sorry. Okay? So 12 combination 8, I'm not sure what that is, but if I multiply 12 combination 8 times 2 to the 8th times 2 to the 8th, I get the coefficient, which is 126,720. So probably that's not something that you would want to do out by hand, to find that term, because multiplying x squared plus 2 times itself 12 times, it would get pretty messy. Okay? Did I say that was the last one?
Yes.
I lied. Okay, so last one, this is quick, okay? Find the fifth term in the expansion of 2x minus 3y to the 10th power. Okay, so this is kind of similar to that last one, but So you're going to have a 2x raised to some power, and a negative 3y raised to some power, okay? And then I'm going to have a 10 over here and something that goes down here, right? And this something and this something have to be the same, yes? Okay? So the fifth term, what is the exponent going to be of this? It's not going to be 5. It's going to be, I think it's going to be 6, right?
Yeah.
Right, because it starts at 10. So 10, 9, 8, 7, 6. You get that? Because the fifth term, you start, like the first term, you would start with this being 10, right? First term, that would be 10. And so the second term would be 9. Third term would be 8, right? Fourth term would be 7. The fifth term, this would be 6, right? And these two need to add together, so what's this going to be? 4. And this agrees with that, so that's going to be a 4 down there, okay? So the exponent of, so I would go, or you could go, this exponent is always going to be 1 less than the term you're looking for. Got it? Yes? You understand that? Yeah? No? Because this one starts at 0 and goes up 1, 2, 3, 4. So this would be 1 less than whatever term you're looking for. So then I could do it all out and figure out the math. So it's going to be a positive number because you're taking negative 3 and raising it to the 4th power. And you're taking 2 and raising it to the 6th power. It's going to be some huge number. But if I did do it all out, I would get 1,088,640 x to the 6, y to the 4th. And if you don't believe me, you can figure that out for yourself. Okay? So that's it. So you can figure out 10 combination 4 with your calculator, 2 to the 6th with your calculator, negative 3 to the 4th with your calculator, and multiply those all together. That gives you that coefficient, right? Okay? And that's how you do that stuff. And that's all, folks. Okay? Applause. You can okay, that's the end. You can, I can, well, watch I didn't start. Oh!